So I thought it might be helpful if I went through the problems that I assigned on the website. They were 52, 54, 58, 61, 63, 66, and 67. Here's 52. I'm not going to do the problems, but I'm going to talk you through how to do them. So this is a chemical neutralization. So you're going to have to take your nitric acid, your HNO3, and you're going to add to that the barium hydroxide. So you recognize this as a double replacement equation. So you find moles of this, then you would need to find moles of this. Then you know that 1 liter is the same thing as 0.0844 moles. So that's your logic on that problem. Okay, question 54 down here, household ammonia as a window cleaner. It gives us the equation right here. You have NH3 plus H plus makes NH4. Okay, so you know this volume and you know this molarity. So could you find the moles of HCl? Yes, volume times molarity. Once you know the moles of HCl, that's also the moles of H plus, because HCl, when it comes apart, turns into H plus and Cl minus. So if you know moles of HCl, you also know moles of H plus. Oops. All right, so you want to know the molarity of the NH3. So if you know the moles of H plus, you can find the moles of NH3 because the 1-to-1 ratio. Then divide by the volume and you have the molarity. So that's the logic on 54. The next one was 58. So 58 right here. All right, you've got two reactions here. So I'm going to go ahead and write the equation out. You've got sodium carbonate, and you're adding that to acetic acid. This is a double replacement reaction where the H from the acetic acid, this H right here, comes over and goes where that is. So, and the sodium goes with the acetate. So I'm going to write acetate as NaC2H3O2. So N acetate C2H3O2, and then with sodium. And then the other product would be H with HCO3, which is just H2CO3. But we know that H2CO3 makes water and carbon dioxide. All right, so then all we have to do is balance the equation. You have to have a 2, whoops. You have to have a 2 here and a 2 here. And we got H2O and CO2. Okay, so now we know the mass of the sodium carbonate. So we know this. Whoops. Could you find that? Moles? Yes. We know the volume and the molarity. There's the volume. There's the molarity of the acetic acid. So can you find moles of that? So the question says, will this resulting solution still be acidic? So when you do the limiting in excess, if there's more of this, it's acidic. And if there's excess acid, it's still acidic. If there's not excess acid, it's not acidic. That's all there is to it. So you got to find out if there is excess acid or not. To do that, you need to know moles of each one. Next question after that was 61. So 61 is down here. Now this is a little bit tricky. So you got to think about it like this. So you're looking for a titration is represented by the molecular view shown in the sketch. So the titration is the same titration that you have up here that we did earlier. Where was that? It was this equation down here. So NH3 plus H plus makes NH4. Okay, so if you have NH3 plus H plus makes NH4. That's the net equation for the titration. So this would be your NH3. So you got 3 H's. This would be NH4. And then this would be the H plus. And so then you figure out based on what you have to count up the pieces, and I cut this off when I took a picture, so I can't do this one. But you're going to count up the pieces. Like here's 3, looks like 4 NH3s. No, NH4s, 4 of these. It seems like there was another one down here. Oh, here I got the book in front of me. 1, 2, 3, 4, 5. So there's 5 NH4s. And there are 1, 2, 3, 4, 5, 6 H pluses. And only 1 NH3. So if you look up here, we have 5 of these. You don't get 5 of those unless you've used up 5 of these. So what you started with, this is, I'll put down start here. You started with 6 of these. 5 of these would require 5 of those because it's all 1-to-1 ratios. So we know we had 5, but there's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's 6 of them in the picture in your book. 1, 2, 3, 4, 5, 6. Yeah, there's 6 of them in your picture. Okay, so that means since there's 6, you must have started with 11 of those, right? Because you used 5 and you have 6 now, so you started with 11 and you didn't start with any of these. So based on that information, you should be able to decide whether it's choice A, choice B, choice C, or choice D, and I'll leave that in your hands. Then we have 63. So 63 is up here. I don't know if I can do this or not. Let's see if I can do this. Bye-bye. Oh, look at that. Okay, now 63 and 66 and 67. So in 63, you got this equation, and it's balanced for you. So you know this many samples, or this many grams sample of the diarsenic trioxide, so you're going to have 0.1078 of that. And then you know the volume, and you don't know the molarity, but you know the volume. So can you find moles of this? Find moles. After you know moles of that, you find moles of this. This wasn't that hard, was it? After you find the moles of that, just divide by the volume and you'll have the molarity. So that brings us to 65. 66. So 66 and 67 required balancing the equation. So this is redox stuff, so you need to watch that other movie I showed you about how to balance redox equations. After you have the redox equations balanced, then you know that it takes this volume and this molarity. So find the moles of the other, or the Mn plus 2, and divide by 0.025 liters, and you'll have the concentration. Then 67, same thing. You've got to balance the equation. Notice, did you notice that this one was in basic solution? I didn't mention that. That one's in basic. So that's the harder of these two problems. You just have to add that extra step about the OHs. So watch that other movie I made. And then down here, we know that we have 25.8 milliliters, and that's the molarity. So you're going to find the concentration of the potassium permanganate, and then find out how many moles you have, and then how many grams. So once you know the moles of sodium oxalate, then you find grams of sodium oxalate. Right? And that's how many grams are in 5 milliliters. So then you have to do a proportion. If you want to know how many, you know how many grams are in 5 milliliters, so how many grams are in 1 liter. And then you work through it from there. So I hope that helped you a little bit. And by the way, I'm going to go ahead and give you the answers. These are the answers that I got for the problem on the back side of the sheet that I gave you in class today. So number 3, the first one, I got 19.5 grams of Cl minus. For the second one, I got 61.6 grams of potassium hydroxide. For the third one, I got 64.4 grams of potassium ion. And for the fourth one I mean, I got 80 grams of precipitate. In case you didn't get the first page finished, for number 2, I got 91.98 grams of copper 2 hydroxide. And then I also got 367.9 grams of mixture. All right. And then I think we all got the answer to number 1. We had 7 grams and 20 grams for our 2 answers. Okay, that's the end of this little short movie.